Welcome to the tutorial on integrated circuits. An integrated circuit is also known as IC, microcircuit, microchip, silicon chip, or simply chip. It's a miniature electronic circuit that consists of semiconductor devices as well as passive components that can be manufactured on the surface of a thin substrate of semiconductor material. The semiconductor devices can be transistors, diodes, and FETs. So let us understand what is a discrete circuit. Any electronic circuit is formed when solid state devices or components are interconnected. This circuit is known as discrete circuit. In this circuit, components are separable. Then, what is the difference between an integrated circuit and a discrete circuit? In an integrated circuit, semiconductor wafer on which thousands or millions of tiny resistors, capacitors, diodes, and transistors are fabricated. The first integrated circuit was developed in 1950s by Jack Kilby of Texas Instruments and Robert Royce of Fairchild Semiconductor. An IC can function as an amplifier, oscillator, gate, flip-flop, timer, counter, computer memory, or a microprocessor. Depending on the application and the type of signal processes, IC can be classified in various categories. Now, let us look into the advantages of IC. The two main advantages of integrated circuits over discrete circuits are cost and performance. The costs are generally low as the chip along with their components are printed as a unit by photolithography. That is, they are not constructed one transistor at a time. The performance is very high because the components switch extremely quickly and efficiently as they consume little power as they are small and very close together. Generations of ICs. Small scale integration were the first integrated circuits which contained only a few transistors. They consisted of circuits containing transistors numbering in the tens. The SSI circuits were vital to early aerospace projects. The Minuteman missile and the Apollo program both needed lightweight digital computers for their inertial guidance systems. The next step in the development of integrated circuits in the late 1960s was that of medium scale integration (MSI), which saw devices which contained hundreds of transistors on each chip. Also, these cost little more to produce than SSI devices and were allowed more complex systems to be produced using smaller circuit boards and less assembly work. Starting in the 1980s was very large scale integration, in short VLSI, which started with hundreds of thousands of transistors and continued beyond several billion transistors. The term ULSI, that stands for ultra large scale integration, was proposed for chips of complexity of more than 1 million transistors. WSI, or wafer scale integration, is a system of building extremely large integrated circuits that uses a whole silicon wafer to produce a single super chip. The name is taken from the term very large scale integration, the current state of the art during the development time of WSI. Next is the system on chip, SoC or SoC, which is an integrated circuit where all the components needed for a computer or other system are included on a single chip. The design of this device can be costly and extremely complex, and also building disparate components on a single piece of silicon could compromise the efficiency of some of its elements. The drawbacks of this device are offset by low manufacturing and assembly costs and by vastly reduced power budget, as the signals among the components are kept on die, much less power is required. The three-dimensional integrated circuit 3D IC has two or more layers of active electronic components. These integrated both horizontally and vertically into a single circuit. The communication between the layers relies on on-die signaling, so the power consumption is lower than that of equivalent separate circuits. Sensible use of short vertical wires can substantially reduce the total wire length for faster operation and efficiency. Advances in integrated circuits. Along with the advanced integrated circuits are that of the cores or microprocessors, which handle many of today's appliances from computers and cellular phones to digital microwave ovens. Integrated circuits have constantly migrated to smaller feature sizes over time, thus allowing more circuitry to be placed on each chip. The increase in capacity per unit area can be used to decrease cost and increase functionality, as seen in Moore's law, where it states that the number of transistors in an integrated circuit doubles every 2 years in a modern interpretation. Normally, as the feature size shrinks, there can be seen improvements in everything. Thank you for watching.